I apologize ahead of time if you can hear my AC in the background. I have window AC. I'm so sorry. All right, well, just listing off the givens that were in the problem of the 100 grams, which is really 0.1 kilograms, but as you'll see, that's just there to let you know, hey, this thing is in reality because it's a puck. And it weighs about this much. It ends up canceling out. The length of the track is 5.1 meters at a 28 degree. I didn't draw that, but this is definitely not to scale. Angles are incorrect. That's saying, oop, that's not a straight line. The length up the slope, basically the hypotenuse of a right triangle, and then that theta is made here. The main thing is if it makes it to the top, that's going to have that height h. I think you can already see where that's kind of going, that if we're making right triangles here with hypotenuses and other parts of the legs, that we're going to have to involve some trig, that 28 degrees. First thing to start off with is that all of the energy, so I made this little bar chart showing how, thankfully, with there being no friction, everything in the initial state is all in the initial energy, which is all kinetic because it's going to be moving at some speed v at the bottom of that hill. And then by the end of it, once it reaches the top of the hill, it'll have only potential energy in the form of gravitational potential energy, mgh, at least in an idealistic sense that it doesn't keep any kinetic energy. I realize I should have put, this should have been kinetic energy K, it should have been potential U, but the point still stands that it'll go from one to the other 100% in an idealistic case without energy loss due to friction. Like I was saying about that whole, there's probably going to be some trig here. The height, it would originally start as sine of theta equals opposite over hypotenuse. Opposite is the height, hypotenuse is L. I skipped a step and put it right to L sine theta. So that just makes the final energy actually equal to mgL sine theta, which is sometimes how you see some people doing it. First step is to conclude that all energy is conserved, meaning either the change is zero or the initial energy equals the final energy. They tell the same story. So replace our terms. 1/2 mv squared equals mgl. You divide by m on both sides to cancel out that m. Multiply both sides by 2 to get rid of that 1/2. And then, sorry, gotta click over my mouse. You'll get v squared equals 2gl sine theta. This technically does have the plus or minus, but since we're assuming that it's going to be going up the hill and not moving away from the hill, the assumed direction is into the, up towards the final point. So I'm going to negate the plus or minus and just say it's the positive answer this time of 2gl sine theta. Again, just repeating that m got canceled because it appeared on both sides. No weird magic business going on here. Replacing terms 9.8, 9.81. They're different approximations for gravitational strength, 5.1, 28 degrees, and you come out with a approximate speed to reach the top of 5.99 meters per second. It was actually like about 5.98, a bunch of decimal things afterwards, but I did it to about 3 significant figures since that was the smallest one in this problem was 2. So I probably should have done 6.0, but I wanted to show that it wasn't exactly 6. It was a little underneath. I hope this helps. Message me in the comments if you have any questions, comments, or concerns on the process here. If there's somewhere else that like your professor or teacher was doing something different, let me know, and I'll do my best to answer that question. Have a good day.